All right, on this problem, it looks like it's a reinforced concrete. Well, maybe not reinforced, probably is. Some kind of concrete structure, tapering. It has a distributed load across the top of 6 kips per foot. And there's a point load here on the side, a horizontal load of 5 kips. And this reaction symbol at A probably indicates that it is a what? Would that be a good place for a pin connection? Not unless you want your structure to be on the ground. So that's probably a fixed connection. So how many unknowns at a fixed connection in 2D? 3. And we're going to draw one free body diagram. That should give us 3 equations. So this should be, again, an easy statically determined problem. So let me go ahead and draw my free body diagram. So I'll assume there's the top edge, and here is the column. At A, again, I will assume that I have a reaction up, a reaction to the right, and a moment. There's my 3 unknowns. Over here on this edge in the horizontal direction, I've got this 5 kip load. And then I've got this uniformly distributed load. How are we going to manage that? Well, as we talked about before, we're probably going to do the work with the concentrated equivalent for the reactions. So I'll indicate that that's the equivalent force. And remember, the magnitude of this force should be the total magnitude under the load. Since it's a rectangle, that's easy. It's just going to be the base, which seems to be 3 plus 12 is 15, times the height, which is 0.6 kips per foot. What is that, 9 kips? And it's going to be right in the middle. So again, this is a total of 15 feet. So that's going to be 7.5. This little part here is 3 feet, so that means that this little part here is 4.5. Did I get that right? No, that's not right. Yeah, it is. Sorry. Did I get that right? Everybody happy with that? This little 4.5 foot dimension is important because that's going to end up probably being the moment arm of the equivalent force about the base. So what should we do? What should we do first? Should I sum moments about this point? Point C. Should I sum moments about? Can I sum moments about C? Sure you can. You can sum moments anywhere you want. That'd be a good place to sum moments. Probably not, because I would write one equation and how many unknowns? 1, 2, 3. How about sum moments at B? Well, that's better. Why is it better? Yeah, AY passes through B, so it wouldn't create any moment. But I'd still have an equation in terms of the moment at AX and then the moment. So, again, not a good place. How about A? Last but not least. Why would A be a good place to start? Yeah, AX and AY pass through A, so I'll just have one unknown, the moment. So let's do that. So again, using right-hand rule as my sign convention, let's sum moments about A. I'm getting bored listening to myself talk. I'm sure you've been bored long ago. So I'm going to start asking questions of you. I'm going to start with our 2 special students in the small table. Mr. Thusius, what's the moment about A due to the 5 kip load? Is it positive or negative? With my sign convention.
Negative.
Negative. So it'd be negative. What's the force? 5 kips. What's the distance? 10. Oh, I forgot that. I'm sorry.
10.
What was it? 10?
10.
Excellent. So, Mr. Montgomery, what's the magnitude? The moment due to this equivalent load about A?
Is that 9?
Positive or negative?
It's gonna be negative.
Negative. 9 kips. And what's its moment arm?
4.5.
4.5. What's left, Mr. Birmingham? Have we accounted for all the moments on the free body diagram? Have we?
Moment
So is it positive or negative the way I drew it?
Positive.
Correct. So one equation and one unknown. The moment at A. So somebody solve that for me. It looks like the moment at A is going to be positive. 50 plus whatever that is. 90.6, I'm guessing. 90.5. And that will be kip feet. Everybody get that? You okay with that? So I got a positive, which just means it's counterclockwise moment. Now later in the course, these sign conventions won't be arbitrary. When we start talking about axial force, shear force, and bending moment, there's sign conventions that you have to use that will all communicate the same. Okay, what's next? Mr. Reddick, what do you want to do? On this problem, I should be more specific. A general question of what do you want to do is, I'd be afraid to actually hear most of your answers. But what do you want to do in this problem to solve for one of the unknowns?
Solve the forces in y.
You want to do it in the y direction? Okay, we'll assume up is positive. So let's sum forces in the y direction. Who's next to you? Don't tell me. Paul. Montre. Hey, not bad. Those memory pills are working. Mr. Montre, what sum the forces in the y direction for me?
Negative 9 kips.
That's correct. What else?
Times 10 feet.
Not times. This is just forces now. We're just summing up the forces, right? So here's a force in the y direction. Got any other forces in the y direction? Correct. Is it up or down?
Up, so it's positive.
Correct. Mr. Mokhtar, you get the easy one. What's the solution to that equation?
Negative.
Positive or negative?
Positive.
How's that? Mr. Deaton, you have a very difficult question to answer. What do we do next?
Sum x.
Correct. Did you have a choice? Miss East, what is the sum of the x? I'm sorry, I can't hear you.
Negative 5.
I'm assuming to the right is positive.
Oh, I didn't look at that. Sorry. Alright, 5 plus x.
That's right. So what is the answer, Mr. Pham?
Ax.
What is ax equal to?
Minus 5.
-5. Now, should we feel sorry for ax because he's -5? No, it's completely what? What is minus and positive? It's not your bank account. It's just, look, it may be. It's just what? Direction. And direction is really arbitrary. And I chose it to be right is positive. That just means ax is going left. Big deal. Okay? If I were to use ax in any subsequent equation, what value would I put in for ax? -5. Cool. So any questions about that? All right.